Dr. Kenneth Blumenfeld is a climate scientist from Minnesota. He works for the Minnesota State Climatology Office, where he provides the state's agencies, communities, and citizens, that's us, with up-to-date scientific information about Minnesota's changing and variable climate. He enjoys telling and hearing weather stories, and often does so long after the workday is done, which we were able to do some of last night, though conversation flowed rather freely into other areas at our happy hour. Thank you so much for joining us for that, Kenny. And I will say unofficially, he recommends the book Man's Search for Meaning. So come on up. We're glad to have you.
Thank you. I'm gonna use this area. Thank you for having me. It's great to be here. My name's Kenny. I'm a little worried about the back row because I spent many classroom sessions in the back row, and I know what happens back there. There's a lot of graphics here, but I'll try and explain it all. And hello, Zoom world. How many? We have some people online. Great. I won't forget about you, I promise. So I'm a state employee. I work for the Department of Natural Resources. For those of you who don't know, the State Climatology Office is just a small little program inside the DNR. There's 3 of us. And some of you probably know my colleague, Pete Boulay. If you work for the Soil Water Conservation District and or are a rainfall observer, you send your reports through the SWCD or to Pete, and he manages the largest volunteer precipitation network in any state in the country. And it's probably the oldest and longest such network in the world. So thanks for your service. We do the same with snow depth, snowfall, all kinds of stuff. Our job as climatologists is to collect, maintain, and serve climate information to the people of Minnesota. And so my job specifically is to help people understand what's going on with our climate. And I started in 2015. I was in the private sector for a couple of years before that, but mostly have been in some form of public service for the last 2 decades, 2.5 decades now, basically since 2000, when I was teaching and also out giving kind of free discussions on the climate and climate change back even 15, 20 years ago. So I'm happy to be up here. I'm glad that since I took a state car on taxpayer time and used taxpayer resources to stay overnight, I'm glad that we had lots of activities planned. Every once in a while, we have to get in a car, drive 3 hours, give a talk for 30 minutes, nobody asks a question, and then go home. And I kind of think, okay, that's good. Did my job, but I'm happy. This has been a very full experience. So thanks so much. Like a lot of you, I am a Minnesotan. Actually I moved out of Madison when I was 1. So I guess, but I grew up in Minnesota. I've always loved our resources. I'm a lakes person. Even though I'm also a city boy. I grew up in Minneapolis and St. Paul, but there's some familiar faces here, and it's good to see those of you I've known previously, and good to see the people I've met and those I haven't met also. So we'll begin. So when we talk about the climate, you have to keep a few things in mind, especially when you talk about how it's changing, because the whole reason that my job exists is that the State Climatology Office was unable to satisfy the increasing demand for requests about what's happening, what's going on with the climate. They just, they were too busy managing rainfall and various data networks, and they were unable to really satisfy the new demands that started arising about 10, 15 years ago, as people increasingly wanted to know, what does this mean for Minnesota? Well, interestingly, those answers aren't really easy to come by. I mean, those of you well, I've been trying to make those answers easier to come by, but we still have work to do. Those of you who have been interested in this issue for years or maybe even decades know that, the primary source of information, there's two primary sources of information. If you think of the root of the word primary, it means one. So it's weird for me to say that there's two primary sources, but there's two main sources for climate information. The science itself, which is the compendium of peer-reviewed literature on, whichever field you're talking about. In this case, it's climate. And data. The data that goes into all of that peer-reviewed research. You really have two options. And, this is still a developing field. Climate change science. There's hundreds of weekly publications about it, but over time, it's evolved to that. And originally is global. It's a global issue, and it is a global issue. So you'd start hearing things in the news about floods, about rising sea level, about storms getting bigger, heat waves getting worse. And then you'd hear about other things, but you might not hear much about Minnesota. We're generally not in the international and even national news with our climate stories here. But think of what state agencies do. They manage resources, or they make decisions, or they allocate funding, or all of the above on behalf of the taxpayers of Minnesota. So we have, in the DNR, we have foresters, we have herds, we have fisheries folks, we have all the state parks and trails, we have natural and wildlands. And you can multiply this by all the other entities that do that. They have to make decisions about Minnesota. It would be helpful to know what's happening in Minnesota. And there was some research that's been done in the 2000s, trying to get a handle on that. But it wasn't all rooted in strict climatology. And so my job is to help people understand Minnesota's different. Geography matters, right? Think of our climate as it is. It's wildly extreme, right? You go from probably hitting the Ely area 35 below at some point this winter, and it was a warm winter in terms of cold weather extremes. In the past, maybe it would have been 45 below or 50 that you hit. But that's still, even 35 below that's beyond what most Americans have ever experienced. And this summer, you're going to be likely to hit 90, 95, 97 maybe. Maybe some parts of northern Minnesota, maybe International Falls is always a good candidate. If we get a heat wave, upper 90s, possible. That's a level of variation that is unique to the center of our continent. I mean, the center of the Eurasian continent gets it too, but it's not really something that you find out near the coasts. Seattle can't relate to that. Boston also cannot relate to it. They get good heat extremes on the East Coast, but they lack the cold weather extremes. And on the West Coast, even the heat extremes are hit or miss. Some years you really get them, and some years you don't at all. And it's not uncommon for the West Coast of the US to have an entire summer where they don't hit 90 degrees. So we have a different climate. We're halfway between the Gulf of Mexico and the Rocky Mountain. We're halfway between, the equator and the North Pole. And then in the middle of the continent, we're equal distance from the Gulf of Mexico and the Canadian tundra. We're also equal distance from the Rocky Mountains and the Atlantic Ocean. When the wind shifts directions, our weather changes pretty dramatically. And our climate, since climate is defined by, it's just the sum of all the weather, it makes sense that our climate really represents where we are. And the same is true with other places. The climate represents where they are too. So our climate is different from California's, from India's, from most other parts of not just the country, but the world. So it shouldn't surprise us that as global temperatures have risen, we've had different symptoms from other parts of the world too, a different response. So I like to keep things focused on Minnesota because there's no shortage of information about what's happening globally. It's super important. But for people who make decisions and manage things and are concerned about resources here, we want to talk about what's changing here in terms of the climate. The second point I always like to point, I always want to play fair. We have a wildly variable climate, lots of ups and downs. Not just from summer to winter, but from one summer to the next, from one winter to the next. We just talked about it. This winter was extremely snowy. It was also very mild and had an unusual amount of rainfall. In previous years, you wouldn't have said that. You might have said we were kind of low on snow, but it was mild. Or you might have said we were low on snow, but it was cold. Or we had lots of dry, powdery snow, something that was kind of lacking this year. So those kind of variations are baked into our climate. They're always going to be there. And at the same time, there are ongoing changes. I'm going to show you some kind of simple ways to keep these things straight. One example is just to think of a friend who you've noticed who's become kind of crabby lately. And you think something's changed, right? What's wrong with this person? They're snapping at me more, they're ornery more, they don't want to do anything, everything's complaining, and you're trying to figure out, okay, I think maybe you identify what you think the change was. But then when you look back, you realize, yeah, but this person was always kind of crabby too. So there becomes an art in knowing the difference between what was just your friend being your friend. And how do I know when now my friend is also reflecting some of these changes that I suspect are ongoing? We have the same thing we have to do with the climate. We have to try and understand which of these extremes is just the normal variability we've always had. Look at the ups and downs. This is Minnesota's annual temperature, just averaged around the state every year from 1895 right through 2022. Each dot is a different year. Obviously, here in Northeast Minnesota, the temperatures would be a bit lower each year than what's represented on the graph. And if we were in southern Minnesota, the temperatures would be a bit higher than what's represented on the graph. But most places are going to track these year-to-year changes pretty similarly. Correlation will be strong. Your eyes tell you the story, but there's a lot in that story, isn't there? The ups and downs, the normal year-to-year or annual or interannual variations, but you also clearly see some kind of upward motion there, right? This would be your trend. Now, the most simple way of describing a trend is to take out all of that variability and just turn it into a straight line and say, okay, Minnesota on average has warmed at about, I'm going to use imperial units here, but a little under a quarter of a degree Fahrenheit per decade, meaning each decade on average, we're getting a little less than a quarter of a degree Fahrenheit warmer than we had been. But you can see, based on the ups and downs, it's not really a constant rate of change. It's more like an average rate of change. So you have to keep in mind the way that we talk about change can also be misleading, just like the way we talk about variations can be misleading. These two things are both true. We have constant ups and downs in our climate, and we're also undergoing persistent changes such that we have a long-term warming rate. And there's other ways you could sort of visualize using something like a moving average that shows you a little of both. It captures some of the trend and some of those variations. But the point is, these things are not at odds with each other. If we have a cold week, which we had this spring, that does not refute this trend line. If we have a cold year even, which you can see, we just had one. 2022 was cold by modern standards, certainly below the trend line. That does not refute or disprove that we've had average increases in our annual temperature here. Similarly, we can't say that each one of these dots way up on the right side of the chart there proves the trend or proves that we have climate change. The way that we know that the climate is changing is because we've had a whole bunch of these. The tendency is for everything to be warmer than it used to be. Look at our warm years up here, generally with one exception, warmer than what we had experienced historically. But look at our cool years. Ooh, this is your smoking gun because they're also warmer than they used to be historically. Look at the last batch of cool years. They were cooler, and before that, cooler, and before that, cooler. There's an upward trend in everything for temperature. All right. You could break this trend line into two pieces, perhaps. Up to about the late middle part of the 20th century, that's 1969. There was a shallow increase in annual temperatures in Minnesota, so less than what we see if we look at that whole period from 1895 through last year. 0.15 of a degree Fahrenheit per decade. So there's warming. This was kind of the background warming after the Industrial Revolution, as we were starting to respond to having more greenhouse gases in the atmosphere. But the inflection point really began around, it depends on which variable you're looking at. It depends on how you look at it. It depends on what part of the world you're looking at. But it really began sometime within a few years of 1970. And from that point on, our rate of warming has tripled from what it was up until that point. So instead of 0.15 degrees Fahrenheit per decade, it's 0.46, which is about 3 times that rate. So the period of most rapid warming has been in the last several decades, but you still have to be careful because we still have, during this period of rapid warming, all of the ups and downs that we've always had. It's just that the average has been for it to be warmer. I'm going to drive out to Yellowstone it's going to be a wild road trip with my children and my mother, who just turned 80. It's going to be great. We're going to leave the Twin Cities in June, elevation 700 feet, and we're going to go up to 10,000 feet, right? Up at the highest parts of the park that you can reach are just under 10,000 feet. We're going up in elevation, but it's not like every mile is higher than the mile before it. And we would never go into a valley as we're heading west and say, nah, we're not going to Yellowstone. We just dropped down 75 feet. We can't be. It's similar. We're going to have these dips, and it's foolish to look at those dips with temperature and say, oh, well, we must not be warming. It's the long-term changes that we're looking at. All right, so here are our observed trends. And at this rate, I'm never going to get through this presentation if I tell a story about every slide. But on an annual basis, Minnesota, northeastern Minnesota, has gotten wetter and warmer. Now, I want to point out, northeastern Minnesota has not gotten wet at the same rate as fast as other parts of Minnesota. You've gotten wetter, precipitation has increased, but not in the way that it has in southeast Minnesota or southern Minnesota, which is one of the fastest wettening parts of the whole country. Our winters, no doubt about it, on average, what you think of as winter, especially if you define it by temperatures, are shorter, with less cold or fewer extremes of cold, but more snowfall. Wow. And less snow cover on average. Now, this year we came out, have had a lot of snow cover. Very strange, but there's so much water in the snow, it takes more energy to remove that kind of snowpack from the landscape. So the snow stuck around for a long time, but that hasn't been the norm. What has been the norm has been warming winters that are generally shorter with more snowfall extremes. And then, we've had these kind of phantom or these throwback winters recently, where it's especially lingered on the late edge longer than we had been used to in previous decades. But the overall trend is shorter winters producing more snow with much fewer and weaker cold weather extremes. This is our biggest change. It's actually, of all of the changes we'll talk about, this is the one that's directly tied to the same mechanism that's causing the global climate to change, that causing global temperatures to increase. That is greenhouse gas concentrations, which basically have their greatest effect during winter when it's coldest. And that, as a result, the coldest times of the year and the coldest parts of the world are the areas that are warming the fastest. All right. In the summertime, it's a little bit counterintuitive. You'd think, well, if the temperatures are increasing, we must be getting hotter summers. But we're really not yet seeing that here in Minnesota. What we've seen is fewer cool nights, more downpours. Even if you're not having a really wet year, we're just more susceptible to big rains, big thunderstorms. And we haven't yet really gotten into those bigger heat waves. And again, I'm talking about a trend meaning there's been a predominant or dominant tendency to have more of something than we used to have. And for summertime heat, we're not there yet. However, we'll talk about this as we move through. I just want to point out, someone had mentioned earlier that it seems like a lot of things about the climate come down to water. And it's true. Anywhere that you talk about climate, it's ultimately going to be about water, because we need it for life. And that's what people ask about the most. But we've gotten wetter, we've had more snowfall, but with less snow cover. That alters the springtime hydrology. We've had more downpours. We've also had more, heavy snowfalls. These are some changes, because everything I said might overwhelm you. I like pointing this out, that not everything is getting, quote, worse in Minnesota. Hey, yeah, we're back. So far, anyway. Now, we had a tough summer in 2021. It was hot, but it was not off the charts hot. And we haven't had yet a collection of these kind of off the charts or near to the top of the charts heat summers that would tell us that there's a trend. However, humidity is beginning to get, I said worsen, because everyone hates high humidity. So we are starting to see more summertime heat and humidity extremes, even if the temperatures on the hottest summer days aren't increasing. Drought, because of the way Minnesota has gotten wet, drought hasn't really increased in Minnesota in terms of frequency, duration, severity, and aerial coverage. Now, you say, well, what about 2021 and 2022? Yeah, those were dry years. We had nasty drought here in Minnesota, but they did not stand out from the historical ranges of drought activity in Minnesota. They actually matched it, or were even in some cases on the kind of light side. They were bad, but we had been in such a wet pattern for decades that we simply forgot what drought was like. By the way, with heat extremes, the time is running out. All areas are virtually certain to have unprecedented or nearly unprecedented heat extremes within the coming decades. We just don't know exactly when this will begin and when we'll draw our unlucky ticket. You've seen it in other places already. And then the last thing is severe convective storms like tornadoes, straight line winds, and hail. Those also are not, quote, worsening, meaning the magnitudes of them aren't increasing. We're not experiencing larger hail than we've ever experienced or bigger tornadoes than we've ever experienced, but we are seeing pretty important changes in the season. And I've got an example from this area to kind of illustrate it. The seasons are expanding. So we're starting to see tornadoes happen and all severe weather, severe thunderstorms earlier in the season and later in the season than used to be typical. All right, I'm going to show you a fun graph here. More graphs. There's a lot of graphs. I kind of do a lot of climate graphs, but I know that you're smart and we can do this. This is Minnesota's average temperature and precipitation. So this time we've got two axes that are both these variables, and we're just plotting a dot at the intersection of each of those values. So from left to right, you're going from cooler to warmer. From bottom to top, you're going from drier to wetter. So each dot just represents, on average around Minnesota, a given year's temperature and precipitation climate for that year. Again, some parts of the state would be different in a given year than that average. The axes in the middle are 20th century averages. So average temperature is plotted through that vertical line in the middle, and the average precipitation is that horizontal line in the middle. If you see a dot in the upper right, that would be a warm and wet year relative to 20th century averages. The lower left would be a cool and a dry year. It's nice and symmetrical, which tells me, okay, for this graph, it's pretty well behaved. There's no unusual movement either side of these axes. But if you look at the key, which most of you can't see, this is data from 1895 through 1986, because when I started doing this, it gave me, I could withhold 30 years and show you what the last 30 years looked like. Now it's more than 30 years, but we're going to do it anyway. So through 1986, our hydroclimate was pretty symmetrical around 20th century averages. After 1986, it kind of jumped a little bit. I'm going to just show you that again. Ooh, not symmetrical around those 20th century axes. In fact, only one of the last, what do I have here, 36 years was cool and dry. This one. The others were some combination of warm and wet. Now, they weren't all warm and wet. Some were cool, some were dry, but the tendency predominantly has been towards warmer and wetter conditions. 2016 was wild. It was warm and wet in a way that no other year had been. 2019 was the state's wettest year on record. You see it up there. There's 2021, very warm but dry. You know, these aren't all records. They're not all records, but you can see, look at what 2016, which is no year that warm was also that wet and vice versa. Look at what it competed with other recent years for that dubious distinction. This has been the shift. It's not every year, it's not all the time, it's not everywhere, but we've shifted to a warmer and wetter based climate in Minnesota. Here are the changes in the precipitation normals from, so normal precipitation or normal temperature, that's a 30-year average taken each decade. So these are just basically 30-year averages of precipitation. I'm going to assume that nobody can see any detail on this map. Here's Minnesota. There's Minnesota. We're in each one right in the middle there. And up here where the far, you can barely see it. This just shows, though, that we had severe drought in the early part of the 20th century, and then we kind of snapped back into a normal climate pattern. We snapped back to where we had. What do we got going on there? Okay. We snapped back to where we had been prior to the drought for a few decades. And then then the downpours started and we got extremely wet. And much of our region in the last 30-year normal period from 1991 to 2020 is the wettest it has ever been in terms of records. Now in Northeastern Minnesota, it's not as true here as it is farther south, but it's still wetter than it had been historically. We have 38 really long-term stations with over 100 years of record in Minnesota, so we can just track each year. What's the biggest rainfall at each station and then take the average. And your eyes tell you the story, what's happening to heavy rainfall. You know, it's kind of inching its way up, and then there's this big check mark towards the end. It's not every year. You still have years that are below the localized average. You still have some years that aren't that different from how they were historically. But we're starting to see, whether we look at the average of the heaviest rainfall or just the absolute heaviest rainfall at any one of these 38 stations, a tendency. Again, plenty of years that look like they've always been, but here you start seeing years where the biggest rainfall with increasing frequency and at increasing magnitudes was really at levels that we hadn't observed historically. Right, so none of those stations had recorded an 8-inch rainfall before the late 1960s. And all of our 8-inch rainfalls in this network have been after that point. So it's not every year, it's not everywhere. It's just that we're seeing increases in general. And heavy rains, you can also, this is a bar graph showing the frequency at those same stations of rains that should have a 10-year recurrence interval using the current standards, or a 100-year recurrence interval, the so-called 100-year storm. People always like to focus on those really big ones, those blockbuster precipitation events. But our biggest changes in the last few decades has been the frequency of these so-called 10-year storms, the ones that would have a 10% probability of occurrence at any place in any given year, have really exceeded historical values by quite a lot. And so this is why we've had more precipitation, we've had more flooding. The 100-year storms, you have to be careful how you interpret them, but by current standards, that 38 station network of long-term stations had not recorded a 100-year storm prior to, using current standards, prior to the mid-1950s. And since then, they're still not super common, but they have become. Okay, I'm just going to click here, do it this way. But they've become closer together, so they become more common. This is actually the right way to talk about 100-year storms. It's not that, oh, Fargo had one and now Rochester had one, so they must be getting more common. You actually have to look at each station relative to its own record. And when we do that, we see they are indeed becoming more common. We've had more of these mega rains where a huge rainfall event covers a large area. This case, it's East Central Minnesota. Look at those, that's a radar loop just showing the constant thunderstorm activity, dropping 6 inches of rain or more over a couple thousand square miles in this case. And it leads to, these have increased in frequency and intensity also. So you get scenes like this in Moose Lake, where you've got a soccer field before and after. Yeah, I mean, they were able to get the kids off the field. Here's Brewery Creek in Duluth before and after the same storm. This is the 2012 flood in Duluth and Two Harbors area. And it's not that these are happening everywhere, every year, all the time. It's just that they're still rare events, but they've become more common. And when we look at the future, all the climate models, they tell us, on average, we're going to keep getting wetter. You have to assume ups and downs along the way, which means we're going to have episodes of dry conditions, we're going to have drought, but most indications are that this part of the world is going to get more precipitation in the decades ahead as temperatures increase. So it's not easy to figure out what that actually means for things like water budgets, because as temperatures increase, you also increase rates of evaporation, and it's not always clear if the precipitation that you're going to get when it comes in, especially when it comes more and more in giant events, it's unclear how much of that offsets the increased evaporation rates. But there's more heavy and extreme precipitation projected too. Don't take any of the detail on these maps too seriously, because these are actually blended from numerous climate models running a bunch of different scenarios. But the sign is pretty obvious. We're going to have more days with heavy precipitation. These would be days that currently would be in the upper 2 percentile for precipitation, becoming more common by a day or so per year on average as you get into the middle of this century. Another interesting change, seasonal snowfall has been on the increase in much of Minnesota, even though what I'm going to show you after this shows how kind of bizarre that seems at first. Duluth just set its seasonal snowfall record, 140 inches. That's several inches higher than the runner-up from the legendary 1995-96 winter. Days with accumulating, so these are Duluth had 29 days with at least 2 inches of snowfall this year. That's a big number. That's a lot. No wonder they broke their record. And we've had more heavy snow on average in Minnesota. So here's how the temperatures have changed. It's the same type of map as the precipitation. And you can see, all you really need to see is this over here. For those on Zoom, I'm pointing to that map in the lower right. Much of the country really started here in the upper Midwest, the previous normal period, but by the current normal period, most of the country is now as warm as it's ever been. And Minnesota is kind of at the center of that. So go us. We're number one. So it shouldn't surprise us that we've seen kind of wild levels of warming. So if we accumulate all of the warming that we've observed since the beginning of the 20th century, you'll see an interesting south to north pattern. Southern Minnesota warming at a rate of about 2 degrees Fahrenheit on an annual average basis. Northern Minnesota warming faster than that, 3.5 degrees Fahrenheit. And that's an annual average. That's actually taking every day and then looking at the trend over every year since 1895. So it seems like a small number. It's actually a lot of warming. And if you split it between the seasons, winter overnight lows in this region, so that means a typical winter night between December and February is now 7+ degrees Fahrenheit warmer than a typical winter night at the beginning of the 20th century. Doesn't mean that every single night. Obviously, you have your cold nights, but a typical one, an average one, is that much warmer. And even in southern Minnesota, it's still typical winter nights, about 5 degrees warmer than it would have been historically. And then over on the right are our summertime days. Now you do see a positive value in northern Minnesota. So the average summertime day is about 1.5 degrees on average warmer than historically. But these trends are not what we call significant, meaning they don't pass certain statistical tests. It's a positive trend, meaning high temperatures are increasing, but not yet in a manner that shows it, we could actually publish that conclusion in a scientific journal, whereas winter has been a slam dunk for years and years now. I mean, the warming is so dramatic. International Falls January temperature on average, overnight low is 10 degrees warmer than it was in the middle of the 20th century. And that's International Falls, the so-called ice box of the nation. So you can combine these two things and find some interesting behavior. This is a great cooperative observer in Western Minnesota, 3-generation farmer family that's been doing it since the late 1800s. The bars are the average annual snowfall or average seasonal snowfall by decade. And you can see that in the 2010s, they got to their highest snowfall on record. That orange line tracks the number of nights between November and March. That's kind of your main snowfall season, where the temperature remained above freezing. So we went into basically record snow the same decade as we went into record winter thaw conditions. We're seeing this is the kind of thing that happened this winter, which is why you didn't have much if you had any ground frost, why you had ice everywhere, why you had compromised snow quality in many places, because you were thawing a lot, even in spite of all of that snowfall. We could see this everywhere. I just use the Twin Cities here because we have a nice long and consistent record, but the winter rain I've actually got a better graph I should have used, but winter rain by any metric has become more common and is becoming more common. And that's between December and February. So days where precipitation is falling, but it's not snow and the temperature is above freezing, that kind of precipitation, which also degrades the snowpack. When we look at the behavior of the snow, this is a busy graph. It's a very Edward Tufte-esque graph, but it shows that even with increased snowfall in Duluth annually, they can't hold on to the snow during winter the same as they used to. So the average snow depth between November and March has declined. That's what those bars show. The lines show on the top the decline by about 25% in the number of days with 6 inches of snow on the ground. The blue middle line here shows the decrease in the number of days between November and March with a foot of snow on the ground. We're seeing this everywhere. And the red line is the increase in the number of days with no snow on the ground between November and March. We're here in Northeast Minnesota, where you have some of the deepest, strongest winter in the country. It can be hard to notice. You have to take really careful observations to notice, because there's so much winter in the bank, but it's been eroded in a manner that we can detect all over the place. And we would see this everywhere. You still have your days with 2.5 feet of snow on the ground. That's no big deal up here. Still do that, but that season has shortened. And the amount of continuous time with deep, deep snow on the ground, on average, we still have variations, this year being an exceptional one, but on average, we've lost the duration and the combined duration and magnitude of the snow cover. Meanwhile, when we look at summertime high temperatures, the thing that I think people first think of when they think of warming, we don't really see a trend here in Minnesota. Again, there's no predominant tendency towards more warm summertime days on a statewide average basis than we used to have. When we look at, this is hard to see these graphs, but I took the Grand Rapids Forest Station. It's probably the closest long-term non-lake influenced, non-Great Lake influenced station in northeastern, north central Minnesota. We could have used Cloquet. It's the same. If we look at the highest temperature of summer, you actually see it's not significant, but you actually see a slight decline. Don't get too carried away with this. I think our number will be up soon enough, but all this is to say that while we've gotten warmer, dramatically so in the wintertime, we have yet to see the extremes of summertime heat get worse than they used to be. We can do the same thing with the count of number of 90-degree days. There's no long-term trend, but do note that 2021 stands out there as having more 90-degree days than any other year, and they've got over 100 years of history at Grand Rapids there, in the same place. So we don't have a trend yet, meaning we can't make a statistical or scientific statement saying there's more hot weather happening now, but we're starting to see signs of what it could look like when we get a hot year on top of an ongoing warming trend that is giving us warmer winters that then would provide a warmer baseline when spring and then summer begin. And just to add to the nuance here, extreme humidity is beginning to increase, albeit slowly, but the days that are really humid and the magnitude of the humidity on those days is inching upwards at most stations. This is again the Twin Cities, where we have by far the longest record. And this is also kind of these are hard variables to work with. You have to do a lot of data editing. But we do see there's a trend. So the highest evening dew point temperature of the year is starting to increase. And then when we pair that with temperatures and compute the heat index, we're seeing on average, the highest heat index value is kind of going up on the decadal scale. So it's not off to the races. It's not launching like a rocket, but it is increasing. And that tells us that maybe the way that we're going to get our extreme heat events in the future won't just be from temperature, but will also be from the combination of temperature and humidity, which means that when we interpret the climate projections that help us understand future, we have to be careful. This is the increase in the number of 90-degree days by the middle of the century, by 2050, 2060. Now, I want to be clear about what this map is showing, because climate folks get beat up a lot for showing the worst case scenarios. This is the best case scenario. This is the rosy, everybody figures it out. International coordination is spectacular. Countries stick to their commitments. but because of the amount of greenhouse gas already in the atmosphere, we still end up, it's not as bad in Northeast Minnesota where 90-degree days aren't that common. So you're only going to see increases on the order of maybe 10 in an average year days, 10 additional days, 5 additional days above 90 degrees compared to now. But look at southwestern and western Minnesota, 25 to 35 additional 90-degree days in a typical summer. And this is a very rosy scenario. And this is getting at the kind of the lag effect of having all of these greenhouse gases in the atmosphere and the fact that global temperatures are increasing, which is just increasing the starting conditions when we get into spring and summer. I'm going to skip this slide because it's always confusing. Severe convective storms. I've got a bunch of graphs that I could show you about, when you normalize for the changes in observation habits, they're really not getting worse, but they're doing things that we've never seen them do before. This one blew our minds. So Minnesota's tornado season, well, think about it. It's generally in the southern and western areas. It's around St. James, right? It's in the Mankato, St. James, and down into southwest Minnesota area. That's the center of tornado activity in Minnesota, Highway 14 and south. But we do get it in central and eastern Minnesota. The main season is mid-April, maybe May, and then June, tailing off July and August, and sometimes lasting into September. Occasionally, we get tornadoes in April, and rarely we get them in March. Historically, this is true. And occasionally, we get tornadoes in Minnesota in October. Well, in 2021, we had a huge number of October tornadoes. And one of them went right up to the international border here in the boundary waters up in Cook County. And it was a big tornado. You can't see from this Forest Service image, but it took out a wide swath of trees, indicating it wasn't just a strong tornado, but it was large. This was the latest tornado on record so far north in Minnesota. We just had never seen it like that. We've had tornadoes in the boundary waters are rare anyway. Having one in October was unthinkable. And of course, while we were sitting there thinking about how unbelievable it was to have an October tornado that far north, in December, we ended up having a 20+ tornado outbreak in southeastern Minnesota. And that became the latest tornado outbreak on record by a month. So the season's expanded, which also expands the geographic range. So it might not be getting worse, but there's nuance to that in terms of, in terms of its intensity, in terms of the number of these things, but there's nuance to it because we're starting to see tornadoes at times and in places where we didn't used to. So let's just summarize all of this because I've gone on for like 3 hours now. The region is wetter and warmer than it used to be. It's been driven mostly by, heavy precipitation events, heavy snow, heavy rain. That's been the real driver of increased precipitation. It's not that it necessarily rains more days or snows more days. It's just that when it rains and snows, it tends to be more. And of course, warmer winters is the real driver of our overall warming trend. The projections indicate both of these trends will continue. And we're going to start seeing heat extremes that we haven't seen yet. You have to keep in mind point number 3, that we're going to keep having this variability, ups and downs. If we get into a big warming trend and then everyone says, oh, see, this is the changing climate, that might be a correct statement, but you have to be aware that the other shoe will fall and you will end up with a cold year and someone's going to say, well, where's your warming now? Just remember that those things aren't at odds with each other. We have a variable and a changing climate. The drought, which is just the hydrological or hydroclimatic variability, is going to also continue. So even though we're trending towards wetter conditions, we're still going to have years that are dry. And when you pair those dry conditions with increased temperatures and especially increased summer temperatures that we expect as we get into the future, we could have pretty nasty drought episodes. All right, so thanks so much for having me here. I look forward to hearing any questions and chatting with you some more before we all take off here. Thank you very much.
We don't have our second in-house microphone, but I'm still going to pass the Zoom microphone. Oh, yeah. I thought you wanted to ask a question, Elton. That would be very like you. I know. It's just...
About northeastern Minnesota's gradually getting warmer, but we're still cold in the winter. Is that affecting, this is about southern Minnesota more, the fact that there's pure snowfall occurrences in winter in the southern part of the state, because that's moisture air is in the air?
Minute, okay. Can we try take two on that? Help me, I want to make sure I'm answering the right question for you.
I'm just trying to understand if, seems like there's bigger, heavier, continuous snowfalls in the southern part of the state. And maybe we winter snowfalls, but not because of our temperatures up here facing in the drier, colder air facing the wetter, moister air down there.
I would probably challenge the premise of that question and say that because Northeast Minnesota has always been the leader of snowfall, it's always, you know, it's rare that it's not the snowiest part of the state. We've actually seen its statistics for snowfall increase faster than anyone else's. What I haven't done, I haven't looked at it proportionally though, to see, well, is it increasing at a larger rate? But in terms of sheer numbers, it's been that even though we've had more winters without much snow than ever before, it's that those 5 or 6 out of 10 winters where you do get snow, you're also getting a historically high amount. And the whole reason that it snows more, okay, so little fun climate thermodynamics for you. We'll make it easy. Everyone on Zoom, you can wake up now. The global temperatures rise, right? And this we already know. And as they rise, this is just physical law, more water evaporates. All right, so, and our main source of water, major source of water is the oceans. So the water comes out of the oceans, goes into the air where it resides as humidity. And so then it's not like it's always more humid because the air is constant turmoil with passing weather systems that can transport moist or dry air or warm air or cool air into a region. It's when those precipitating weather systems send moisture up this way, there tends to be more available than there used to be. And in the wintertime, where it actually takes less moisture to trip you into the point where you can produce precipitation and get it to start snowing if it's cold enough, we've actually seen big increases, especially in northern Minnesota's wintertime precipitation climatology. So it's a good question, but I'd say it has, it's something that we're actually observing at least as much in northern Minnesota as in southern Minnesota. In fact, northern and northeastern Minnesota have been the only areas where we've had years with continuous snowpack when the rest of the state couldn't find any. So good for you. You're our stewards of snowfall and snowpack. Thank you.
Yes. Fun question.
I don't know if that mic's on.
Sorry, this is for the Zoom crowd. If you could just.
Okay. Okay. Well, thanks for coming and visiting with us today. But the question I have is this changing climate that is definitely happening. What effect would you care to speculate what effect it's going to have on some of our lake levels and perhaps some of the fish species that live in them?
Okay, so for the Zoom crowd, that the question was, oh, they did get it. I see. So this is the problem. Hello. Okay, great. So they got the question. So this is a really tough question, and I'm not a fisheries expert. The main thing is cold water fish species they're kind of most at risk, especially in environments where the water is most susceptible to warming. So where it's really deep, it's not, my understanding is it's not as perilous as in some of those transitional zones. The DNR's fisheries folks have been concerned about cold water species and have been trying to work on basically a migration program to move them into find refuge for cold water fish species. Lake temperatures are already showing signs of increasing, which makes sense because we have a longer open water season and it's tending to be warmer during that time. So that makes sense that air temperature changes don't always work into the water, but if you give it a long enough season, it does. In terms of lake level, this is where things get interesting, and I don't have a definitive answer because the drivers of lake level are both, runoff. Well, I shouldn't say both. It's precipitation falling plus runoff plus any groundwater influences. And the one thing that we're pretty sure is going to happen is that our precipitation is going to become increasingly episodic. Now, we don't know if these episodes are going to be weeks long. Sometimes we get stuck in a wet pattern and a lot of precipitation accumulates over a week or two, or if they're just going to come in one-day dumps. But pretty much all of the climate models and even some of the data show that Minnesota's, and not just Minnesota, a lot of continental areas are transitioning to either the same number or even fewer days with precipitation, but more precipitation overall, indicating more episodes. And what makes that a little bit uncertain when you start driving these other like lake level models is there's an uncertainty about how much time there's going to be in between these episodes. And, fortunately and unfortunately, I have to stick with what I do and what I can say I know and understand and what I can say I don't understand. And I get to say I stand with the science. But the unfortunate thing is we then have to accept that there's tremendous nuance in here. I've seen some suggestion that lake levels will on average increase in areas that got a lot of precipitation if that summertime warming is kept at a lower level. But I've also seen some models where the lake levels just drop. So all we know is there's probably going to be more precipitation. There's almost certainly going to be warmer conditions, but because of the uncertainties in the timing of that precipitation, it's unclear how that's going to get integrated into the whole kind of the larger hydrologic system. How much of it's just going to run off versus how much is going to get into the ground and recharge groundwater supplies. And that's something we've already seen a lot of variability in with our wet years and wet episodes already. So I think it's fair to assume that's going to continue. But beyond that, I would have to defer to people who have more expertise than me. It's a really good question. I wish I had a better answer for you. Thank you.
Yeah. Doubt it.
The one thing I was wondering is why the Twin Cities seem to work through the grassroots because of we don't have the population up here, so therefore we have a lot more trees and ground cover and this and that and the other, whereas parts of the cities they're just bulldozing everything and slapping up houses.
So are you talking about on the precipitation graph?
Yes, or
map?
or even the temperature warming graph is do the trees and just the general habitat here.
Yeah, I'd say Northeast Minnesota is warming much faster than the Twin Cities area. So the trees aren't bailing you out of that one. It is true for precipitation. In fact, it's hard to see on but the map on the lower right, there's really a gradient from south to north where the colors become deeper and more intense as you get up to the Canadian border. It's a great set of maps. It doesn't work so well from 30 feet back on a fairly small screen. But for precipitation, we're just looking at in these maps here, this one, that's just precipitation quantity. It doesn't tell you anything about what happens to that precipitation once it falls. No doubt about it, we have far more impervious surfaces in the Twin Cities, and they're covered with oil and stuff like that. And that sloshes off into the rivers, or some of it gets into the ground. But no doubt about that affects the vulnerability to runoff, contamination, and flooding from urban areas. But that wouldn't explain the precipitation differences. And it's hard to know. I don't have a good explanation for why Northeastern Minnesota, at least through the past few decades, showed a slower precipitation increase than other areas. We don't know if it has to do with agriculture and the proximity to really deep, shallow, but intense moisture coming off of corn in the summer, or if it's just kind of the intensification of the same process that drives summertime thunderstorms, which tend to be more common in southern Minnesota than northern and northeastern Minnesota. So a really good question again. Sorry, I get the proof that questions are good is that the speaker can't answer them fully and then has to apologize.
Politicians who are climate deniers, are they choosing not to look at the information? They're too stupid to analyze it. Or they're just lying.
You guys have been a great crowd. Thank you so much. I think I can answer that artfully. I am a public employee. I work for everyone in any group, irrespective of their political orientation, can ask for information, and I will try to help them. I would say in general, with folks who are uncomfortable with or stating some kind of opposition to the scientific consensus, it's very clear. You either understand the science or you don't. And you're either representing it honestly or you aren't. I can't speak to anyone's motivations, but the majority of people that have told me that they don't believe in climate change, what they really end up meaning once I talk to them is that they don't understand it. And anyone who's kind of willing to, listen and think about it. I've had a lot of people who they might surprise you with their openness to accepting, oh, so that's what you're all talking about. Because I thought it was all about, and then they get into whatever their pet policy that they're opposed to is. Saying, no, actually climate change is just the change in your climate, which is the change in your sort of long-term weather conditions. And if you've worked outside, if you're a farmer, you've probably seen these. If you spent a lot of time observing, you've probably seen these, and most people have. And if you expose them to the information, they're open to it. If somebody knows this, there is no alternative science reality here. So if somebody is professing to not be on the side of the science, then, and it's not true that they don't understand it, then they are probably being dishonest about it. And I'm just saying that from experience, and it's not a judgment, but when I'm confronted with that in my own work, I'm trying to spread my time out evenly, and someone who's not open or not being honest they're going to be harder to serve for me. So I'll let you conclude what that might mean about whoever you might have in mind. But I can tell you that in my experience, that there's a pretty narrow and almost shrunken window that's all but dissolved to actually refute the science. You can quibble about certain specific findings, but the larger body of science it's incredibly solid. So thanks, good question. Gosh, another one that I got to answer incompletely.
Thank you.
Thank you so much. I appreciate it.